Alright, so let's just see if we are live and okay, perfect. Hi, hello, afternoon, dear students. How are you all? So I hope that everybody is in the best of their health, and today we are going to have a very important session about the organic chemistry for grade 10. Okay, so I hope that you are very much ready. Please grab your pen and paper for noting down the important questions of organic chemistry. So this whole session we will be discussing some of the important topics and of course the questions related to that. Okay, in this particular session we have covered the hydrocarbons, that is alkanes, alkenes, alkynes, then their methods of preparations and the various chemical reactions and the questions that could be asked from those particular topics. About me, I am Ritika, your chemistry educator. I have completed my engineering in electronics and communication and have been awarded grade A by Cambridge English USL. Okay, so without wasting any further time, we will be going with the questions. Okay. Now in these questions, what are the topics that we have basically taken? We have taken the organic chemistry, the introduction, then we went on to the properties. Okay, and after that we went to the nomenclature, the hydrocarbons, that is alkanes, alkenes and alkynes. Let's quickly get started. So the very first question, it's saying that what are the properties that enable carbon to form a large number of compounds. Okay, so if I talk about carbon, see, there are hundreds of elements which are known to us, right? So why is it that only carbon has the capacity to form a large number of compounds, or why do we have a separate branch of chemistry, that is the organic chemistry, only because of carbon? So there are two basic reasons why carbon is able to form these thousands and millions of compounds. Those two properties are, first is tetravalency. Okay, talking about tetravalency, see, the atomic number of carbon, it is I'm sorry, the atomic number of carbon is 6. So with this, the electronic configuration, it will be 2 and 4. Now this thing means that carbon, it has got 4 outermost electrons. That means it has got 4 electrons in the valence shell. Now if I talk about the 4 electrons in the valence shell, it can neither donate or it can neither gain the 4 electrons to achieve a stable configuration. That means the carbon needs to share the electrons, right? If I talk about metals, they are having 1 electron, so they easily give out their 1 electron. If I talk about halogens, they are having 7 electrons, so they easily take 1 electron in order to achieve a stable configuration. But with this carbon, the problem is the 4 electrons, it either has to give out 4 or take 4. So that's not very easy. It leads to great instability. So that is why it goes for sharing of electrons. So basically, tetravalency means the valency of 4, okay, of carbon, which allows it to share the electrons. Okay, and to form the bonding. Okay, so it is the mutual sharing of electrons. Next is catenation. So basically, what do we mean by catenation? It is the self-linking of carbon, and because of this self-linking, it is able to form the chains, that is the chains of different types, that is straight chain or branched chain, or a closed, that is cyclic chain, and it is also able to form different bonds, that is single bond, double bond or triple bond. So these are the basic properties, right? If I go for straight chain, this is what the straight chain looks like. If I go for a branched chain, it can have the branches, and cyclic chain, it forms a closed cyclic structure. Okay, So this is the basic reason. And talking about the bonding, so it can form double bond as in alkenes, a single bond as in alkanes, and a triple bond as in alkynes. And these are the properties which can be considered for such a large number of carbon atoms. Now the type of questions that again can be asked from this particular question, you could just be asked to define the catenation, or you could be asked to define tetravalency, okay, or you could also be asked that carbon has a unique nature, how. Okay, so the answer remains same, but the questions can be asked in different ways. Okay, so kindly be thorough with what is asked in the question. Read your question 2 or 3 times. Try to understand the question rather than just jumping on to writing the answers quickly. Okay, try to understand. Many a times only catenation is asked, or many a times only tetravalency is asked. Okay, so please go through the questions and then go for answer writing. Okay, next is what are organic compounds. So basically these are compounds made up of carbon and hydrogen. So the main, or I would say the important or essential compound over here, element over here, it is carbon. Okay, so they are basically made up of carbon, hydrogen, and some of the other elements. They can be nitrogen, they can be oxygen, they can be phosphorus, sulfur, chlorine, etc., etc. Okay, now the properties that we generally see of organic compounds, it is they are forming the covalent bonds. Their melting and boiling point is generally low, so they have low melting and boiling point. Talking about their solubility, so they are insoluble in water, but they are very well soluble in the organic solvents. Okay, alright, so moving on to the next question, differentiate between the organic and inorganic compounds. Now this is the question which can be asked as your long answer question. Sorry. Now over here we will be taking certain things on the basis of which we will be describing the organic and inorganic compounds. So the very first thing is, okay, let's go for differentiation, yeah, between organic and inorganic. Now talking about the organic compounds, the very essential component, or I would say the very essential atom over here is carbon. Okay, and in the inorganic, carbon, it is okay, it can be present, but it is not very necessary. Okay, so over here we can say carbon is essential, and in the case of inorganic, carbon is not essential. Okay, then talking about the organic compound, they can exist as solid, liquid, or gaseous compounds. Okay, organic compounds can exist as all the 3 states. It can be existing as solid or liquid or gas, and inorganic compounds, they exist generally as the solid compounds. Okay, the third one is their melting and boiling point are generally low. So we can say that they have low melting point and boiling point. And over here in the case of inorganic, they generally have high melting and boiling points. Alright. Then if I talk about their solubility, the organic compounds, they are not soluble in water, but they are readily soluble in the organic solvents such as chloroform or ether or benzene, etc. So they are soluble in organic solvents. And the inorganic solvents, on the contrary, they are soluble in water, but they are not soluble in the organic solvents. Correct? Alright, talking about their reaction. So over here they undergo covalent bonding and they show molecular reaction. Okay, and they form the electrovalent or ionic bonds. Okay, and next thing is in the organic compounds you will be seeing the properties such as catenation and isomerism. Okay, so these are the properties of organic compounds. That means we are able to see these properties only in the organic compounds. Inorganic compounds do not show the property of catenation and isomerism. So what is the basic difference? In organic compounds, carbon is very necessary. They exist as solid, liquid or gases. Then they have low melting boiling point. They are insoluble in water but very well soluble in organic solvents. They undergo covalent bonding and they show the property of catenation and isomerism. Okay, so students, you can join us on the Telegram. Okay, the links are provided to you in the description box. You can also join the official channel of Unacademy ICSE to receive. Correct. In the unsaturated compounds we have alkenes and alkynes. Okay, so these are the compounds. Hope that up till here everything is pretty much clear. Now moving on to next, that is the saturated and unsaturated hydrocarbons and the difference between them. So if I talk about the saturated and unsaturated hydrocarbons, let's talk about saturated first. So over here in the saturated compound we will be having the single bond, that is the carbon-carbon single bond is present. Okay, then talking about the valency of carbon, they are satisfied by hydrogen. Okay, and next is they undergo substitution reaction. The next category is unsaturated compounds. So the unsaturated compounds, they are containing the carbon-carbon double or triple bond. Okay, then the valency of carbon, they are not satisfied just completely by hydrogen. We are also having a double or a triple bond to satisfy the valencies, and they undergo addition reactions. Okay, so I hope that up till here everything is perfectly clear to you. Okay, talking about class subscription. So students, in this month of February you're going to get a mega offer, that is if you're purchasing the subscription for grade 9 to 12 you are getting 2-month free extension if you go for 12-month or above subscription. Okay, and even if you purchase the plus subscription for any duration, you can get a flat 10% discount, and this offer, it is valid for first 500 subscribers. So kindly make sure that you fall into the category of first 500 subscribers. Next is the one-shot revision series that we are going for grade 9 and 10 from in the month of February. Okay, so over here we are going to solve and practice some of the very important questions for your examinations. Okay, so kindly make sure that you attend the classes and take the full advantage of the sessions. Okay, next is define isomerism. So basically isomerism, it is a phenomena in which the organic compounds, they are having same molecular formula but they are having different structures. So they are having same molecular formula but different structural formula. Okay, so due to this, their chemical properties would be similar, but physical properties, they will change. Okay, for example, if I talk about butane. Butane, it has got 4 carbon atoms. Okay, C4H10. Now if I talk about the isomers, the very first isomer is this one. So it's CH3, CH2, CH2 and CH3. Okay, that is N-butane. Correct. Now what if I bring one carbon atom it down? That is somewhat like this. Okay, over here the structure, it will be known as isobutane or 2-methyl propane. Okay, so these are the isomers of butane. Moving on to next question. Give the IUPAC name and structure of isomers of pentane. In pentane we are having 5 carbon atoms, so it will be C5H12. Okay, the very first structure is the straight chain one, so it is N-pentane, or we could just say it as pentane. Next can be okay, so over here this structure, it will be named as 2-methyl butane. Why? Because on second carbon we are having a methyl group attached, right? Okay, next we can have 2 carbon atoms in the or on the middle atom. Okay, so it will look like so it is named either as neopentane, or if I go for the IUPAC name, it will be 2,2 dimethyl propane. Okay, so these are the structure of the isomers of pentane. Hope that you are very much clear with this. Next is give the laboratory preparation of methane and ethane. Okay, so for methane we take the sodium acetate. Okay, and for ethane we take sodium propanoid and we make it to react with soda lime. So let's see how the reactions happen. Let's go for methane first. So what do we take? We take sodium acetate and sodium hydroxide. Over here we will be providing it with calcium oxide and heat. Okay, and what do we get? We get methane plus sodium carbonate. So just write the names of the compounds that we get, especially the main product that we needed. So we can get it from sodium acetate and soda lime. And talking about ethane, we can get it using sodium propanoid. Okay, so this is sodium propanoid. When we make it to react with soda lime, what do we get? We get ethane and sodium carbonate. Similarly, writing the name for the main products that we are getting. Okay, so I hope that up till here everything is clear. We will be moving on to next question, that is give the substitution reaction for methane. So substitution reaction basically means taking the place, right? Now if I go for the substitution reaction of methane, when it reacts with chlorine, the conditions are under UV light, ultraviolet light, it gives chloromethane plus HCl. Okay. I'm sorry. Now this reaction doesn't stop here. Okay, it's a continuous reaction. So basically from methane we got chloromethane. Now this chloromethane, it again undergoes the reaction with chlorine, same conditions, and over here we get dichloromethane. How? One H is removed and one chlorine is added. So subsequently this is the thing that will happen. So from dichloromethane we will be getting trichloromethane. Okay, and it is also known as chloroform. And at the last, this trichloromethane, it will react with chlorine to give tetrachloromethane. And here the reaction stops. Why? Because all the 4 valencies of carbon, they are now satisfied by using chlorine. Okay, perfect. Okay, next is give the reaction for oxidation of ethane using potassium dichromate. Okay, so what is potassium dichromate? K2Cr2O7. Okay, so when the ethane or any alkane undergoes the oxidation, let's see what are the products that we get. Okay, so we have first of all ethane. That is C2H6. When it undergoes oxidation, what's the compound we have taken? Potassium dichromate. Okay, we get alcohol, that is ethanol, C2H5OH. When it again undergoes oxidation using same compound, we get an aldehyde, that is ethanol, CH3CHO. On further oxidation, it gives us the acid, that is ethanoic acid. It is CH3COOH. And at the last, it gives us carbon dioxide and water. Okay. But if I go for the basic reaction, this is what we get. Okay. From the alkane, we get the alcohol. From alcohol, we get aldehyde. And from aldehyde, we are getting the acid. Okay. So on continuous oxidation, these are the products that we get. I hope that this thing is clear. Moving on to next one, define polymerization. So what is polymerization? It is a process in which the simple molecules of ethene, they join together and they form large molecules. Okay, so basically simple molecules of ethene, they are joining together to form large molecules. Condition is high temperature and high pressure. Okay, now over here this is ethene. We are giving high temperature and high pressure. Okay, so what do we get? Basically we get the polythene, which is a polymer. Okay. Okay, next is give the preparation, general method of preparation of ethyne. So how is ethyne prepared? It is prepared from the methane. Okay, so how do we get it? We take methane, okay, and we give electric arc. The temperature is almost 1500 degrees Celsius. And what do we get? We get ethyne. So please remember the methods of preparation. Okay, it could be asked for ethane, ethene, ethyne. Okay, so various methods of preparation, kindly learn it by heart. Okay, next is give the IUPAC name of the following compound. So if I go for the IUPAC naming, there are certain rules that we should be following for the IUPAC names, right? So the very first is, going for the longest carbon chain. Then we have to select the functional groups accordingly. So the very first compound, it is okay. So if this is our compound, the very first thing that we need to remember is to select the longest carbon chain. Okay. Now this becomes our longest carbon chain, in which we are having 7 carbon atoms. Since all the carbon, they are joined by a single covalent bond, so it will be an alkane. Correct. And on the third carbon, we are having an ethyl group, so it will be 3-ethyl heptane. Correct. Okay, moving on to next question. The next question is, okay, so this is your compound. Now see, wherever we start the numbering from, we will be getting the group on third carbon. Okay, and over here, see, this is the methyl group and this is ethyl group. Okay, so how we will be writing it? It will be named as 3-methyl 3-ethyl heptane. Correct. Now let's take one example of a functional group. Okay, and we are having CH3. Okay, so over here, if I go for the longest chain, this is the longest chain. Okay, and here I am getting a functional group on second carbon. Okay, I'll start numbering from here, because over here I'll be getting the group on second carbon, so it will be named as 5-carbon pentane 2-ol. Okay, so this is how the naming is done. Now what if we have the halogens attached? So let's say that this is the longest carbon chain and we are having 2 groups. So over here we will be getting, or we will be going alphabetically, right? Starting from here, we have total 6 carbons. Okay, the groups are attached on second and fourth. So what will be the name? 2-bromo, 4-chloro. So it's on fourth carbon that we are having the chlorine group. Hexane. Correct. So this is the basic name of the compound that is given. I hope that you might have understood this very much clearly. Okay, talking about a very important information about Prodigy exam. So students, you are having a last chance. Okay, the test, it is scheduled on 27 February, that is tomorrow, for all the students of grade 7 to 10. From 12 to 1 p.m. you are going to have this Prodigy test, and you can win amazing scholarships and amazing prizes. So kindly do not forget to enroll. Also students, you can enroll yourself into the upcoming batches. Okay, so we are having these batches which have already been started, and in this we are going for a crash course which is very important for your examination. So kindly make sure that you enroll in these courses. And if you like this video, kindly press on like button, kindly share this video, and also subscribe to the channel of Unacademy so that you do not miss out the sessions over here. So we will be meeting in the next session, students, in which we will be learning a bit more about your term 2 syllabus. Till then, keep studying, keep learning. All the very best for your preparations. Thank you.